Hi guys, today I will try to give you an overview of Polygon filling algorithms. Uh, we will discuss about three polygon filling algorithms uh, named Scanline algorithm. Then we will discuss about flood fill algorithm. Then we will discuss about boundary fill algorithm. To effectively understand these algorithms, you need to study these two concepts from the previous tutorial. First one is inside-outside test, and second one is neighbors of pixels. So what these two concepts actually tell: inside by using inside-outside test, you can figure out if a pixel is inside the polygon or outside the polygon. In the diagram you can see one polygon made with bold white lines. This pixel is, for example, inside the polygon, and we have some outside pixels here. Now, using this inside outside test, you have two algorithms here, very easy: odd even rule and winding number method. You can figure out whether a pixel is residing inside the polygon or if it is outside the polygon. And next, neighborhood of pixels. So what does neighborhood concept says? Say xy, this is your pixel in concern. Now by using this concept you can figure out the coordinates of its adjacent pixel. Now let me go back to our previous diagram. If the coordinate of this pixel is x and y, so by using simple observation you can figure out the coordinates of adjacent pixel. If the coordinate of this pixel is xy, then pixel to its right will have coordinate x, y plus 1. There is no change in x coordinate, and y coordinate has been incremented by 1. Now come to the left pixel. It has coordinate x, y minus 1. Upper pixel x minus 1 y, lower pixel x plus 1 y. So before going into the discussions about polygon filling algorithm, if you have not studied these two concepts yet, first read this and try to understand them clearly. Then come back to this video once again. Now come to Scanline polygon filling algorithm. The first algorithm that we are going to discuss about is Scanline polygon filling algorithm. So how you can understand this? First, try to define a polygon in mathematical terms. For that, At first, let me draw one x-axis and draw y-axis. So here is our y-axis. This is x-axis and this is your y-axis. Now let me draw one polygon. So this is our polygon. Now try to figure out how you can define this polygon. A polygon can be defined in terms of vertices and edges. So let me define the vertices. Let us assume that this is our vertex v1 and coordinate is x1, y1. This is vertex v2, coordinate is x2, y2. This is vertex v3, coordinate is x3, y3. This is vertex v4 and coordinate is x4, y4. So using these vertices you can define the polygon mathematically. Now if you observe this polygon, you can clearly see that this y2 is the maximum y value present in this polygon for any vertex. So let me define this as y max. Y max equals to y2. Next, try to find out for all the vertices which vertex has minimum y coordinate value. You can see that this y3 is the minimum y value for any vertex coordinate present in this polygon. So y min becomes y3. So now in the scanline polygon filling algorithm, what is a scanline? In between y max and y min, you have to find out a x-axis parallel line. So what is the definition of a x-axis parallel line? X-axis parallel line can be defined as x-axis parallel line y equals to sum yi. Yi is a variable. Now what should be the value of yi? For this algorithm to work, yi should be something like y min less than yi less than y max. So this is your constraint for those x-axis parallel scan lines. Now Up to this point of time, what do we know? We know the definition of the vertices. The vertices are mathematically defined, and we have established a definition for our scan lines. Now this is going to be a recursive algorithm. So now let me draw one scan line. Say this is our first scan line. Now from where this scanning should start? The next question is from where you should start scanning the polygon. For this, you have to find a variable called xmin, and in this variable you will store the minimum x value from all the vertices, and your scan line should start from a x value which is less than this xmin. By doing this, you are ensuring that your scan line starts scanning from outside the polygon. Give it a thought. So in this example, our xmin is either x1 or x4. So we will start scanning from left of this x1 and x4. For example, say something from here. And for each pixel on the scan line, do an inside-outside test by following those two methods, either even or odd method or bending number method. If the pixel is outside on the scan line, then go to the next pixel and do the same test again. Now go to the next pixel. Here we hit the pixel boundary. So what you have to do, you have to take a note of this intersection point. Say this is P1. So P1 is the first point which is on the pixel boundary as well as inside the polygon. Next, move on pixel by pixel, and as I am moving, you can clearly see that our inside-outside test will test positive as all the pixels now are inside the polygon. After some time, while scanning, we will hit another edge of the polygon. Say this point is now P2, and after P2 we are outside the polygon. So now from this discussion we can conclude that all the points lying between P1 and P2 on the scan line are inside the polygon. So what you have to do now? You have to color or pixelate all the pixels along this scan line. So this pixelation or polygon filling was done for a particular scan line. Next, recursively you have to change the value of this yi. So by doing this, you will move to the next scan line and do the same procedure. Say this is P3 and on the other side we will have P4. Computers giving some trouble. Okay, here is our P4. Now again pixel it along the scan line. If you do this for each and every pixel in between y max and y min, you can see that your entire polygon will be filled by some predefined color. And this is the idea behind polygon fill, Scanline polygon filling algorithm. So now let me go back to the algorithm. What the algorithm is saying. Algorithm looks something like this. This algorithm works by intersecting scan line with polygon edges. If you can recall, we have found the intersection of the scan line with polygon edges and fills the polygon between pairs of intersection. If we go back to our diagram, we have filled the intersection between pair of points, between points P1 and P2, P3 and P4. So what are the steps? Find out y min and y max for the given polygon. At first we have calculated y max and y min for the given polygon. Next, scan line intersects with each edge of the polygon from y min to y max. Scan line intersects with each edge of the polygon in between y max and y min. Next, sort the intersection points in increasing order of x coordinates from P0 to P1, P1, P2 and P2, P3, something like this. So what we have done here, we have sorted the points between P1 and P2 in increasing order of x. Next, fill all those pair of coordinates that are inside the polygon and ignore the alternate pairs. We have filled all the pairs, all the points which are inside the polygon and ignored everything outside. So this was the idea behind Scanline polygon filling algorithm. In the next video, I will share with you the brief description of this flat fill and boundary fill algorithm. So next, go to the following video.